Okay, so this question is May 2019, question number 10. AIA says, find the matrix product. All right, so we're going to multiply these two matrices. Let me write them back because I don't think we need all this space. I can write it back. -1, 3, 4, H, multiplied by K, 5. All right, so we're multiplying a 2 by 2 matrix by a 2 by 1 matrix. We should end up with another 2 by 1 matrix. I'm going to multiply the top row by the 1 column and end up with the top value in the answer. First element in the row by the first element in the column. So -1 times K is -K. Second element in the row times the second element in the column. So this is 3 times 5, which is 15. Then I'm going to go down to the bottom. First element in the row, which is 4, times the first element in the column, which is K. So this is 4 times K is 4K. Then second element in the row, H, by the second element in the column, 5. So H times 5 is 5H. So for 2 marks, that's what we needed to do. Next, we're told that -1, 3, 4H multiplied by K5 is equal to 0, 0. But we did work out the left-hand side already. We did it in the previous section. So we can say -K plus 15, 4K plus 5H, and this is equal to 0, 0. Now, when two matrices are equal, corresponding elements are equal. Corresponding means in the same position. So -K plus 15 is equal to 0. Therefore, 15 here, -K goes over and become positive. So K is equal to 15. All right, so next, let's go down to the bottom. 4K plus 5H is equal to 0. But K is 15, so 4 times 15 plus 5H is equal to 0. 4 times 15 is 60. Positive 60 goes over and become negative. So I can say 5H is equal to 60. Sorry, not positive 60, negative 60. Wait, wrong thing. All right, let's use the rubber. So 5H, remember 4 times 15 is 60. Positive 60 goes over and become negative 60. Then we divide both sides by 5. And so we get H is equal to -12. So K is equal to 15 and H is equal to -12. All right, that's sort of forcing it there and then. Oh, let's write it here. So H is equal to -12. Let's turn the page. All right, this says using a matrix method, solve the simultaneous equation. So the first thing we're going to write this, represent the simultaneous equation as a matrix equation. So I'm taking the coefficients. So this is 2, -5, 3, 1, multiplied by x, y, and this is equal to 5, 13. All right. So now this is in the form AX is equal to B. That's the form. Now, to solve a matrix equation of this form, we're going to write back x and multiply over here by A inverse. So this is A inverse times B. So if we multiply the right side by the inverse of the matrix A, we will determine the values of x and y, or we will determine the matrix xy. So the first thing is to find A inverse. Now A inverse is equal to 1 over the determinant of A times adjoint A. Now the determinant of A is 2 times 1 minus 3 times minus 5. So this is 2 plus 15, and so we get 17. All right, and so A inverse would be equal to 1 over the determinant, which is 17, times adjoint A. Now for adjoint A, you're going to switch around the leading diagonal elements. So 1 goes here, 2 goes here. The 3 and the 5 stay where they are, but their signs change. So minus 3 and positive 5. All right, so let's finish this now. It means therefore that x, which is xy, is equal to A inverse, which is 1 over 17, 1 minus 3, 5, 2, times B, which is 5, 13. You're going to multiply the two matrices and then multiply by 1 over 17. So I write back my 1 over 17. Let's multiply the two matrices. 1 times 5 is 5, minus 3 times 13 is minus 39. 5 times 5 is 25. And 2 times 13 is 26. So what we end up here with is 1 over 17. And this becomes minus 34 and positive 51. Now multiplying by 1 over 17 is the same as dividing by 17. So this becomes minus 34 divided by 17 and 51 divided by 17. And so what we have is that xy would be equal to minus 2, positive 3. So now I can say, therefore, x is equal to minus 2 and y is equal to 3 are the solutions of the simultaneous equation. So this is x is equal to minus 2 and y is equal to 3 are the solutions of the simultaneous equation. Next page. All right, so the B part of the question is on vectors. It says relative to the origin O, which is the point 0, 0, the position vectors of the points A and B are OA is 9, 0 and OB is 3, 6. What else we are told? It says the points D and E are on AB and OA relative, respectively, and are such that AD is 1/3 of AB, all right, and OE is 1/3 of OA. The following diagram illustrates this information. This is asking us to express express the following vectors in the form AB. Well, using triangular vectors is not as difficult as it might look. AB would actually be, you start at AO plus OB. Let's try the law of vectors. All right, first of all, we have OA. OA is 90. So AO is minus OA. So this is minus 90 plus OB, which is 3, 6. So this becomes minus 9 plus 3 and 0 plus 6. So AB is minus 6, positive 6. All right, so that's AB. It is minus 6, positive 6. All right, next. All right, this is I. All right, apparently, let's turn the page and see what II is asking for. II is asking for OD. So let's go back to our diagram. OD would be OA plus AD. OD would be OA plus AD. So OD would be OA plus AD. So this is OA plus 1/3 AB. AD is 1/3 of AB. OA is 90 plus 1/3 AB, which is minus 6, minus 6, 6. And so what we end up with is what? 9 minus 3, because, sorry, 9 minus 2, because multiplying by 1/3 is the same as saying divide by 3, and the bottom part is 0 plus 2. All right, so OD is the vector 7, 2. Lastly, BE, let's go back to our diagram. BE, I could say that BE is equal to BO plus OE. So BE is equal to BO plus OE. Now, BO, this is minus OB. If we want, we could write that. Plus OE, which is 1/3 of OA. So this is minus 3, 6. I think that's true. It's 3, 6 plus 1/3 of 9, 0. So this is minus 3 plus 3. Because multiplying by 1/3 is the same as saying divide by 3. Minus 6 plus 0. 0 divided by 3 is still 0. So BE is minus 3 plus 3 is 0. And minus 6 plus 0 is minus 6. All right. And that would be the end of the question.